Hello students, tonight we are going to talk about a new topic called the probability, 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 colon. And actually, this topic originates from gambling. And therefore in this chapter, we are going to talk about quite a number of problems on coin tossing, rolling a dice, or drawing a card from a pack of playing cards. And in fact, probability actually means it's a measure of how likely something is going to happen. And if an event has a higher probability, it means that it is very likely to happen. And if the event has a low probability, then we can say that it is unlikely to happen. And just let me introduce one of the founders of probability, and he is called Blaise Pascal. This guy is called Blaise Pascal. He's a French mathematician and inventor, and he is also one of the founder of probability. And this is another invention from Blaise Pascal, which is called the Pascal triangle or Pascal triangle. And if you study M1 or M2 in Form 4, you will learn this triangle in your math lesson. And if you study ICT in your Form 4 or Form 5 lesson, then you will have a chance to write some Pascal program. This is what we call the Pascal program. So now we can take a very simple example on rolling a fair dice. So this is a dice. And a fair dice actually means the probability, the chance of getting any one number from the dice is equal. That means fair. It actually means the chances of getting any one number is equal. And therefore, let's say, suppose we are going to find the probability of getting the number 3 by rolling a fair dice. And since we all know there are a total of 6 faces on a dice. 1, 2, 3, 4, 5, 6. There are a total of 6 possible, we call this outcomes. 6 possible outcomes. And actually, the number 3 is only one of the 6 possible outcomes. 1 out of 6. So this actually gives us a measure on how likely this event is going to happen, getting the number 3 by rolling a fair dice. There is only 1 chance out of 6 possible outcomes. So therefore, how can we express this in mathematics? Probably this will be a ratio 1 to 6, and therefore you will usually write the results of a probability in a fraction, which is 1 over 6. And let's see another example. If we are going to find the probability of getting the number 1 by rolling a fair dice, again, the number 1 is only one of the 6 possible outcomes. So therefore, again, we have 6 as the denominator, and the numerator will also be 1. So again, this will be 1 over 6. But what about getting an even number? Even number. So how many numbers are even out of these 6 possible outcomes? And actually we can count them. We have 2, 4, 6. So there will be a total of 3 outcomes out of the 6 possible outcomes. So our answer will be 3 over 6. And after simplifying, we get 1 over 2. And look that we have 3 outcomes here. We call this the favorable outcomes. Favorable means this is what we want. This favorable actually means this is what we want, because we want even number. So we just count. There are 1, 2, 3 favorable outcomes. And let's see another simple example on tossing a fair coin. And let's see, this is the two faces of a $10 coin of Hong Kong. And the face with a number, we call this a tail, T. And the face with a head, or actually is a flower, we call this the head. And since by tossing a coin, either a head or tail will come up, there will be a total of two possible outcomes. And the probability of getting a head will be 1 out of 2. Therefore, this will be 1/2. Similarly, the probability of getting a tail will also be 1 outcome over 2 possible outcomes. And in the case of a fair coin, fair actually means the probability of getting a head or tail is equal. So we call this a fair coin. And if a coin is not fair, then these two probabilities will not be equal to each other. Okay, let's look at example 1. A letter is chosen randomly from the word excellent. Randomly means 隨機. It actually means the chance of selecting any character from the word excellence is the same. Every character has the same chance of being selected. Find the probability of choosing each of the following letters, X, L, E. So we can just do this by counting. We simply count the number of characters in the word excellent. For example, getting an X, we write this in this way. The letter P followed by a bracket. We simply write the letter X inside the bracket. The probability of getting the letter X. And the denominator will be the total number of possible outcomes. So there will be 1, 2, 3, 4, 5, 6, 7, 8, 9. A total of 9 characters, 9 possible outcomes. But X, can we find X in this word? So actually we can find 1 and only 1. So there will be only 1 favorable outcomes. So the answer will be 1/9. Getting an L. This is quite similar. Again, the numerator is 9. The denominator, L, we can find only 1, 2, 2L. So this will be 2/9. And part C, getting the letter E. Again, we have the 9 as the denominator. And we have 1, 2, 3, 3 E's. So this will be 3/9 and then 1/3. And actually, I can add another part D here. For example, find the probability of choosing the letter A. Again, we have 9 as the denominator. But can we find the letter A in this word excellent? And actually, there are no A. Yeah? So the numerator will be 0. So this will be 0/9, and then the probability becomes 0. And we call this such kinds of event impossible event. That is, it is not possible, impossible to happen. This event, we cannot find the letter A in the word excellent. Okay, example 2. 3 zeng is a 2-digit number, 3 something, where zeng is an integer from 0 to 9. Inclusive means including 0 and 9. 包埋頭尾嘅0、9都包埋。Find the probability that the 2-digit number is a multiple of 4. And again, we can make use of counting to solve this problem. And we can simply write down all the numbers starting with 3, all the 2-digit number starting with 3. 37, 38, 39. And we have to find out that how many of these 2-digit numbers is a multiple of 4. Therefore, we have to check whether this number can be divided or divisible by 4. And we can see that 32, 36, and there's no more. So, the probability that the number is a multiple of 4 is we have a total of 10 numbers. There are 10 possible outcomes. So 10 will be our denominator. And we have only 2 favorable outcomes, 32 and 36. So the answer will be 1/5. And example 3, we have a bar chart here showing the number of students living in Hong Kong Island, Kowloon Peninsula, and the New Territories. And we can see that there are 3 students living in Hong Kong Island and 18 students living in Kowloon and 11 students living in the New Territories. And if a student is selected at random from this class, find the probability that the student lives in Kowloon. So the answer for part A will be, we have a total of 32 students, 3 plus 18 plus 11. We have 32. And there are 18 students living in the Kowloon side. So this will be our number of favorable outcomes. And this is our total number of possible outcomes. So the answer will be 9/16. And for part B, find the probability that the student does not live in the New Territories. So, not live in NT. So there are a total of 32 students, and 3 plus 18 students does not live in New Territories because they live in the Hong Kong Island and the Kowloon Peninsula. So this will be 3 plus 18. We have 21/32. Okay, example 4. A card is drawn at random from a pack of, let's say, 52 playing cards. What is the probability that the card drawn is a queen, a diamond, black or red? And of course, the best way to do this is to show all the 52 playing cards here. And we have 4 different suits in the pack of playing cards. We have club, spade, heart, and diamond. And in each suit, we have 13 cards. We have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Therefore, we have a total of 4 times 13 cards, which is 52 playing cards. And now we can come to part A. What is the probability that the card drawn is a queen? So we have 4 queens here. We have the club queen, spade queen, heart queen, the diamond queen. And therefore the answer for part A will be 4/52. We have 4 favorable outcomes because we have 4 queens. And we have a total of 52 possible outcomes. So this will be 1/13. And for part B, a diamond. And we can just count how many diamonds are here. We have 1, 2, 3, 4. Of course, we have 13 diamonds from ace to king. So therefore, our answer will be 13/52. Which is 1/4. And for part C, the probability of getting a black diamond. Again, denominator 52. And how many black diamonds are there? Diamond, black. Good? Since this is a diamond. Black diamond. Oh, I'm being tricked by this problem. We cannot find any black diamond because all the diamonds, they're actually red in color. So there are no favorable outcomes, 0 favorable outcomes. So therefore this will be 0. And in fact, this is what we call an impossible event. We cannot find a black diamond. And finally, part D, the card is either black or red. So we have 26 black cards and 26 red cards. So there are a total of 52 either black or red cards. So this will be 1. 52 over 52 equals to 1. And we call this a certain event. This must happen because we cannot find other colors in this pack of playing cards. It is either black or red. So this will be 1. So finally, we write this impossible event for 0 probabilities and certain event for probabilities equals to 1. And as requested by some of the students, and they hope that I can record some video on some higher order thinking problems, hard problems, or more difficult problems. So this is this one, question number 21 from exercise 5A. It's rather a tricky problem. And it shows the number of boys and girls who like and dislike swimming in this table. And a student is chosen randomly from this group. What is the probability that the student is a boy who likes swimming? And so for part A, we have a boy who likes swim. And the total number of possible outcomes will be the sum of all these 4 numbers. And therefore we can sum up this. There are 40 boys and a total of 35 girls. So the total number of boys and girls will be 75. And we have a boy who likes swimming. A boy who likes swimming. So this part is the boys like swimming, dislike swimming. So there are only 22 boys who like swimming. So our numerator will be 22. The number of favorable outcomes will be 22. And for part B, a student who dislikes swimming. And the event actually indicates it is only a student. And it really does not matter whether he or she is a boy or girl. It really doesn't matter whether the student is a boy or girl. So, again, the denominator will be 75. And who dislike swimming? So we have 2 parts here. This one 18 and this one 20. So there will be 18 plus 20 students who dislike swimming. 18 plus 20. So this will be 38 over 75. And finally, for part C, the selected student is a boy. So again, we have 75 as the denominator. And out of these 75 students, we have a total of 40 boys, 22 plus 18. So this will be 40 over 75. So we can simplify this. We have 8 over 15. And that's all for this section 5.1, Introduction to Probability. And good night.